Review solutions for the Chapter 6 review. First question asks you which type of family each of these triangles comes from. That could be Pythagorean triples, 3, 4, 5, 5, 12, 13, 7, 24, 25, 8, 15, 17. Could be 45, 45, 90, 30, 60, 90, those kinds of things. So first one here, we've got a 4. We've got a 4 radical 3 and an 8. That follows the 30, 60, 90 pattern. B, 9, 12, and 15 all have a greatest common factor of 3. If you divide that out, you get a 3, 4, 5 triangle. C, if you divide everything by 2, you get a 5 and a 12, and that's coming from a 5, 12, 13 triangle. And then the last one, next to the last one here, we've got a right triangle with 2 congruent sides. That's going to make it an isosceles right triangle, which means it's got 2 congruent angles. That's a 45, 45, 90 triangle. And finally, this next to last one here. Looks kind of weird. You've got this fraction. And then I realized, oh, if I have a fraction here, maybe if I double this side and I double this side, if I double this side, I get a 17. If I double that side, I get an 8. This is an 8, 15, 17 triangle that was halved in side length. Okay? Find missing side lengths of these triangles. All right, if we look at this first one here, greatest common factor here is 2. We divide by 2. This is 8. This is 17. This would be coming from an 8, 15, 17 triangle that was doubled. So that missing side is going to be 30. This is a 7, 24, 25 right triangle here. Let's see, this one down here is a 30, 60, 90. So you can take half the 10 and get 5. You can multiply by radical 3 to get that side there. This one, if we divide out the GCF of 3, we get a 3 and a 4 and a 5. So it's a 3, 4, 5 triangle tripled in size. So it's going to be a 9, 12, 15. All right. F is a triple. It's a 9, 40, 41. But if you don't know the triple, you have to use the Pythagorean theorem. All right, this one's interesting. Again, there's a 3.5. If I double that, it's 7. If I double 12, it's 24. That would be a 7, 24, 25 pattern, but it's all divided by 2. Half of 25 is 12.5, and that would be the missing side. All right, this one here, oh, this is interesting. I was going to do the Pythagorean theorem, but I noticed the greatest common factor is radical 5. 3 got multiplied by radical 5. 5 got multiplied by radical 5. So if I divide out the greatest common factor of radical 5, it's a little 3, 4, 5 triple. That got multiplied by radical 5. So 4 radical 5 is going to be the missing side length there. This one, the short side gets multiplied by radical 3 to give you 15. So you're going to divide 15 by radical 3. And if you rationalize your denominator there, you're going to end up with 15 radical 3 over 3, which is 5 radical 3 for this side. And then you can double 5 radical 3 and get 10 radical 3 for this side. This is a 5, 12, 13 doubled, so that side's going to be 26. And finally, this is a 45, 45, 90. You multiply the side lengths by radical 2 to get 8, so you're going to divide 8 by radical 2. And you get a missing side of 4 radical 2 when you rationalize your denominator. All right. The next one, we want the area of this equilateral triangle with 5 centimeter sides. I would use the side squared over 4 radical 3 formula. 5 squared over 4 radical 3. That's just going to be 25 fourths. Whoops. Just going to be 25 fourths radical 3. That can be written a couple of different ways. 25 fourths, that's the same thing as 6 1/4, for example, radical 3. You could come in here and you could drop a perpendicular in here. This side's going to be 5 halves or 2.5, and the height is going to be 2.5 radical 3, or you could write that as 5 halves radical 3, because that's a little 30, 60, 90 triangle. You could take 1/2 the base times the height. That'd be 1/2 of 5 times that height of 5 halves radical 3. And if you multiply all that out, you get the same 25 over 4 radical 3. 14, or number 4, Humphrey skis 2 kilometers north and 2 west and 1 north and so on. I think people often think that you're supposed to find these two hypotenuses of these triangles and add them together. But if the slope isn't constant, we're going up 2 over 2, then we go up 1 and over 2. If you connect your starting point to your ending point, it's not actually going to be a straight line along here. This slope here is going to be different than that slope there. And so really you want to know, how far did you go up total? Well, we went up 2 and 1, so we went up 3. How far did you go over? Well, you went over 2 and over another 2, so you went over 4 total. So if he goes, so basically you're turning it into a big right triangle like this. And so he's going up 3 and over 4, and that distance between the 2 points ends up being 5. You could also plot this on a coordinate plane. You can use the distance formula to find the distance between the points. Number 5, altitude is 8 radical 3. These are little 30, 60, 90 triangles. So this side is going to be 8. Full side is going to be 16. Area of a triangle is half the base times the height. Base is 16. The height's 8 radical 3. It's going to end up being 64 radical 3 square units. Rhombuses are parallelograms in number 6. Parallelograms have diagonals that bisect each other, not necessarily congruent, but they bisect each other. And so we've got the 12 gets broken up into a 6 and a 6. The 16 gets broken up into an 8 and an 8. And the diagonals of rhombuses are perpendicular. So this is a little 6, 8, 10 triangle here. These are all little 6, 8, 10 triangles. And so we have a 40 unit perimeter. Number 7, you can draw a right triangle inside your solid. And so that base there is a 6 by 7 base. You can use the Pythagorean theorem there, 6 squared plus 7 squared. And that'll end up being the square root of 85, which I don't think simplifies. And then we can do the Pythagorean theorem again. We can do, I've got the square root of 85 in the 8, and I'm looking for this side here. So radical 85 squared plus 8 squared is equal to c squared. And that's going to end up being 149 is c squared, and we can take the square root. C is going to be the square root of 149, and I do not believe that breaks down. Finally, number 8, this cube has a diagonal of 7 radical 6. Cube diagonals, if you have an x by x by x cube, the diagonal will always be x radical 3. And so as a result, you can multiply side lengths by radical 3 to get that diagonal. You can divide the diagonal length by radical 3 to get the length of a side. And so in this case, it's going to end up being 7 radical 2.